Okay, Assalamualaikum and hi everyone. So today is the last subtopic for the chapter 1, which is 1.4 charges in a uniform electric field. So what you have to know in this topic is how the charge move in a uniform electric field. Okay, so learning objective 1.4a explain qualitatively with the aid of diagram the motion of charge in a uniform electric field. Okay, so explain qualitatively, maksudnya you have to explain secara explanation with the aid of diagram. You have to know how to draw a diagram, the motion of a charge, and charge here can be either positive or negative charge in a uniform electric field. So uniform electric field biasanya dia berada di parallel plate. Okay, parallel plate. So maksudnya electric field kita which is E yang kita belajar in subtopic 1.2 dia sekata. Okay, so E sekata dia berada di parallel plate. Okay, so in this subtopic ataupun in this 1.4 we will have 4 cases. Okay, so we go to the first case is A, stationary charge. So what is stationary charge? Okay, this is very simple one. It said that consider a stationary particle of charge Q0. Okay, so charge can be either positive or negative charge, and mass M is placed in a uniform electric field, which is in a parallel plate. The electric force is exerted on the charge is given by F equals to Q0 E. Okay, so basically, okay, you have a plate. Okay, we'll explain it. You have a plate here. Okay, so you have a plate here, then you placekan you have a plate. This is positive plate and this is negative plate. So daripada positif akan keluar electric field pergi ke negative plate. And we know sebab electric field is E, E dia akan keluar daripada positif dan dia akan masuk dekat negatif. Dan dekat semua plate ni akan ada electric field. Okay, so E. So if you place, maksudnya kamu letakkan sahaja, bila kamu letakkan initial velocity is equals to 0, kamu letakkan satu charge dekat tengah-tengah ni, what will happen to the charge? Okay, charge for example, I use positive charge. So positive charge, kamu kata, oh positive akan attracted to the negative plate. Okay, why positive akan attracted to the negative plate? Because it has a attraction force. So akan ada electric force here. So bila akan ada electric force dekat situ, maksudnya charge saya akan bergerak ke bawah. So bila dia bergerak, dia akan ada acceleration juga ke bawah. Okay, kenapa dia boleh bergerak? Sebab dia attract. Kan ini positif, ini negatif, so dia akan attract. So bila attract, dia akan ada electrostatic force. Okay, same goes to the second one. If I have a negative charge here, saya letak saja. So if I letak initial velocity equals to 0, I put one charge here. So daripada electric field memang daripada positif masuk ke negative plate. Itu electric field in a uniform plate. Okay, so akan ada electric field dekat sini. So this, the yellow one is all the electric field. So I have a uniform electric field. Saya letak satu charge dekat sini. I put one negative charge. So kamu kata, oh negative will attracted to the positive plate. Okay, so kenapa dia boleh attract ke positive plate? Sebab dia ada electric force ataupun dia ada electrostatic force. So bila dia ada electrostatic force, dia tertarik ke atas dan dia akan ada acceleration juga ke atas. Right? So itu case yang pertama. So as you can see that Q0 can be either positive or negative charge. Macam saya kata tadi, kalau saya letak positif dekat sini, dia akan tertarik ke negative plate. Okay, so kenapa dia tertarik? Sebab dia ada electric force. Positive charge, force experienced by charge is in the same direction as the electric field. Okay, sebab kamu kata this is the electric field, the red one is the electric field. So electric force akan sama arah dengan electric field. Okay, tetapi kalau kamu letak satu negative charge dekat sini, negative akan attract ke positive plate. Okay, so negative attract to the positive plate dan menyebabkan the electric force in the opposite direction as the electric field. Electric field yang warna merah. The red one is the electric field. Okay, then the blue one is the electric force. So they in the opposite direction. Kenapa? field yang merah ni sentiasa positif pergi negatif. Ini sentiasa ke sini. Okay. Tapi kalau kamu terbalikkan plate, contoh atas negatif bawah positif, so atas akan ke sini lah. Tapi kamu punya charge negatif, force ni ke bawah. Right? So itu case yang pertama. Since only electric force exerted on the particle, does this force contribute the net force cause the particle to accelerate? So akan ada force. Kita belajar in chapter 4 semester 1, force is equals to MA. But in this case, force kita ialah electric force. So electric force is equals to E is equals to F over Q. So F is also equals to EQ. So akan ada acceleration. To calculate the acceleration, we use A is equals to EQ over M. Okay, so Q is the charge, boleh jadi positif ataupun negatif charge. Mass pun boleh tahu is either mass proton ke mass elektron ke. Kalau proton dan elektron dia dah bagi kat list of constant. Okay, charge pun, nilai charge ni pun kalau proton ataupun elektron dia dah ada kat list of constant. Right, so the acceleration is equals to Q naught E over M, and the unit for acceleration is always meter per second square. Because the electric field is uniform, constant in magnitude and direction, then the acceleration of the particle is constant. Okay, sebabkan E constant, sebab tahu A is proportional to E. So E constant. So A also constant. Right? Okay, so itu case yang pertama. Okay, we go to the second case. Okay, second case B, charge moving perpendicular to the electric field. To the field, yes, to the electric field. Consider an electron with mass m enters a uniform electric field perpendicular with an initial velocity u. The electric force will cause the electron to move along a parabolic path towards the lower plate according to the sign of the charge as shown below. Okay, so tadi case yang pertama, kamu ada parallel plate, kamu ada plate. Kalau dekat parallel plate akan ada uniform electric field. E, daripada positif pergi ke negatif. I think this E terbalik yang this one. Daripada positif pergi ke negatif. Okay, positif pergi ke negatif. But now, yang case tadi saya letak sahaja satu charge dekat sini. It's either saya letak satu positif ataupun saya letak satu negatif charge. Dia tak ada initial velocity. Case yang kedua ini, dia masuk. So, bila dia masuk, dia bergerak dan dia ada initial velocity. So, it has a initial velocity sebab dia masuk, tapi dia masuk 90 darjah perpendicular. So, kita punya E ke sini, ke bawah ataupun ke atas. Kita punya charge masuk perpendicular 90 darjah. So bila dia masuk 90 darjah, dia ialah perpendicular to E. So bila dia masuk, okay, for example, I have plate here. Atas positif, bawah negatif, so akan ada electric field ke bawah. So bila ada electric field ke bawah, so ada satu positive charge yang masuk. Masuk. So what will happen to the charge? Okay, secara logiknya charge saya positif, bawah ini negatif. So charge saya akan attracted to the negative plate. Bila dia attract, dia tak terus masuk, terus menjatuh. Dia gerak dulu sebab dia ada velocity, dia bergerak, lama-lama dia akan deflected ke bawah. And this deflected we call as a parabolic path. Ni kita panggil sebagai parabolic path. So dia bergerak, lama-lama dia akan attract ke bawah. Okay. And it said here positive charge, the positive charge will be deflected and move along a parabolic path toward the negative plates. Okay, and what if we have a negative charge? So bila saya ada negative charge, sama juga dia masuk 90 darjah. So bila dia masuk, lama-lama dia akan attracted to the positive plate dan membentuk parabolic path. So ada orang tanya saya, so negative charge will be deflected and move along the parabolic path towards the positive plates. Okay. For example here, yang ini kan, what happen kalau saya letak positive charge? So positive charge, dia masuk 90 darjah, so positif takkan tertarik dengan positif. Positif takkan tertarik dengan positif. So positif will membentuk parabolic path towards the negative plate. So dia boleh juga bergerak macam ni as long as dia parabolic path. Okay. Okay, the path made by the electron is similar to the motion of ball in a projected horizontally above the ground. So macam chapter 2 semester 1 which is projectile motion. So projectile motion, so if you still remember, the component of electron velocity after pass through the electric field are given by, okay, so bila dia bergerak, dia akan ada x component and y component. Okay, so dia akan ada x component and y component. Okay. So, untuk ini, kalau projectile motion, kita tahu kita akan ada x component and y component. Okay, x component, y component. So, kita belajar kita ada Stova dan kita ada 3 formula. So, untuk x, ux, dia masuk dengan ux dekat sini. Dia masuk dengan u in x component sebab dia masuk horizontally, dia tak masuk vertically. So, us akan ada nilai dan us always sama dengan Vx. So, y, uy-nya always equals to 0 sebab dia tak masuk in y component. Okay. Dan us sama dengan Vx. So, Vx is equals to ux. But Vy, you need to calculate using a formula. It's either you boleh guna Void ataupun Voice. Vy equals to uyt minus 1 over 2 ayt square ataupun, no, this is suited. Void. Vy is equals to, Vy equals to uy minus ayt or what then was Vy square equals to uy square minus 2 asy. Okay, but uy is equals to 0. Okay, so you can calculate Vy, but Sy and Sx, so Sx is equals to uxt plus half at square, but V and x is constant velocity, so acceleration kosong. So Sx is always equals to uxt, but Sy equals to uyt minus 1 over 2 ayt square, so uy is equals to 0. So negative half ayt square. Alright. Okay, so kita tahu kita boleh kira komponen x dan komponen y is either by using this formula untuk ux dan uy, vx dan vy. So vy is equals to negative ayt ataupun vy square equals to negative 2asy, dan sx equals to uxt ataupun sy equals to negative half ayt square. But in the first component, kita belajar a is equals to e q over m. So we boleh substitute this a inside here, inside all the equation yang ada a. Okay, so kalau kita substitute balik, kita akan dapat is 1 sy equals to (1 over 2 eq over m t square). Okay, so ini untuk kes yang kedua. Okay, that's why this is konsep sahaja. So ini, tapi yang ini dalam nota kamu dia mention electron. So that's why dia terus gunakan E kecil. But it can be, it's either electron ataupun proton, any charge. So dia simbolnya ialah Q. Okay, if you still don't understand, I will show you in the example. Alright, so same juga tadi, saya explain sekali lagi. Dia masuk 90 darjah dengan E. So bila dia masuk positive charge, dia akan attracted to the negative plate. So bila attracted to the negative plate, so dia akan membentuk parabolic path. Okay, but if I have a negative charge dia akan masuk 90 degree. So 90 degree, dia akan attracted to the positive plate dan membentuk parabolic path ke atas. So it can be dia terlekat dekat plate, ataupun dia juga boleh, kalau is too laju, dia terlalu laju, dia bentuk parabolic path, tapi dia akan keluar daripada plate, but still in a parabolic path. Okay, We go to the third case, which is charge moving parallel to the field. Tadi charge perpendicular to the field. Now charge parallel to the field. So the electric force on the positive charge is in the same direction as to its motion. The positive charge accelerates along a straight line. Okay, so I have a positive charge here dan saya bagi initial velocity dekat dia. So bila positif, dia akan attracted to the negative plate. But it has initial velocity, so dia akan accelerate towards negative plate. Okay, so dia akan, contoh saya letak, dan dia ada initial velocity, so obviously dia akan attracted to the negative plate. Dan dia akan ada acceleration. Okay, the electric force on the negative charge is in the opposite direction of to its motion. Negative charge decelerate. Okay, so saya ada negative charge. Negative charge, saya bagi initial velocity dekat dia. Adakah dia akan attracted to negative plate? Tidak. So that's why dia bergerak, tetapi dia decelerate. Okay, so negatif dengan negatif dia tak akan attract, but it has initial velocity here, toward here. Dan dia akan decelerate sebab dia same charge. Right, this one positive and negative, so dia accelerate. Lajulah dia ke situ. This one negative and negative, so dia akan repel, tetapi dia ada initial velocity, so dia akan bergerak, tetapi semakin lama semakin perlahan. Right. Okay, and the last one, charge in a dynamic equilibrium. So to know the hint in the question, di case yang keempat, you have to find these three keywords. The first one is said that no deflection. The second one, constant velocity. And the third one, acceleration equals to 0. So if you found these three keywords, so it is a dynamic equilibrium case. So what is dynamic equilibrium? Dynamic equilibrium means the charge move with a constant velocity. Maksudnya, kita ada satu charge dekat sini, dia masuk. So negative charge, sepatutnya negative akan attracted to the positive plate. But charge kita tak attract membentuk parabolic path. Dia bergerak constant je velocity dia, dia masuk, negatif, dia masuk, dan dia terus keluar. Dia tak deflect. Okay? So, dia tak deflect, so kita panggil dia sebagai dynamic equilibrium. Right? Dan dia bergerak at a constant velocity. The negative charge particle will experience electric force towards the plate. Okay, macam mana saya nak pastikan yang negative charge saya, bila dia masuk, dia tak tertarik dekat positive plate. Okay, so in this case, kita consider the weight. So, bila kita tahu, force, bila dia masuk akan ada force sebab dia ialah negatif, akan tertarik ke atas. So, dia akan ada electric force ke atas. But it also has the weight. So, weight sentiasa ke bawah. By using chapter 4, summation of force in Y is equals to MA. But it has a constant velocity. So, acceleration equals to 0. Summation of force is equals to 0 sebab A equals to 0. Right? So, force yang ada ialah FE ke atas dan weight ke bawah. Minus W equals to 0. So, FE is equals to W. So, kalau saya nak cari apa-apa nilai, FE is equals to EQ from the definition and weight equals to mg. So, I can rearrange the equation. Apa yang saya nak. Kalau saya nak mass, saya boleh cari mass EQ over G. The nilai G always 9.81 meter per second square. Alright. So, negative charge experience force towards the plate. So, that's why bila charge ini masuk, dia takkan berbentuk parabolic path. Dia boleh keluar dalam bentuk dynamic equilibrium with a constant velocity. Sebab kita consider weight. Untuk kes yang kedua tadi, kita tak consider weight. Alright? Only particle with this constant speed can pass through without being deflected by the field. Alright? So, maksudnya force dengan weight tu kena sama. Baru dia boleh keluar dengan dynamic equilibrium. Right? So, for example here, okay. Saya ada positif, this one, kes yang ketiga. Okay. Negative plate. So, negatif, dia akan tertarik ke atas, positif. So, akan ada FE. So, bila ada FE, tertarik ke atas, FE sebab negatif dan positif, dia tertarik. Tapi dia ada weight ke bawah. So, that's why dia boleh keluar dalam bentuk dynamic equilibrium. Velocity, ini U. Right? Kalau saya ada positif, okay, so positif, masuk sini positif. Saya tahu weight sentiasa ke bawah. Dan positif akan attract to the negative. So force ke bawah. So this one, dia takkan keluar dalam bentuk di sini. Dia takkan keluar dekat sini. Sebab dua-dua force ni ke bawah. So dia akan membentuk parabolic path. Sebab dua-dua force dekat bawah. Alright? Okay, so that's for the 1.4. And we have one more, which is 1.4b. Use E equals to delta V over D for a uniform electric field. Okay, so kalau uniform electric field, before this kita belajar electric field ada dua formula. E equals to force over charge dan E equals to K Q over R square. This is the two equation for E before this. But ini untuk charge. I mean untuk charge yang macam ini. Right? So kalau charge yang berada uniform E. Okay, kalau charge itu uniform, maksudnya dia berada di parallel plate. You boleh kira dia punya E by using formula delta V over D. Well, delta V is the potential difference, maksudnya V final tolak V initial dan D ialah the separation distance ini. Antara plate positif dan negatif, dia akan ada nilai D, which is the distance between the plates. So D. So E equals to delta V over D. And for this one, the unit, kita tak guna Newton per Coulomb sebab kita guna volt per meter. Unit dia. Right? So this is a very simple one. Kalau kamu jumpa plate, dia minta find electric field, kita guna delta V over D. Right? So that's for 1.4.